Running non-metallic cable within the open web truss space above a drop ceiling might not be considered an open run, as the cable could be seen as protected within the truss. However, there are several National Electrical Code, or NEC, requirements that you should be aware of. Firstly, NEC Section 334.15b requires that non-metallic cable be installed in a raceway or otherwise protected from physical damage. While the truss space may provide some protection, it is not automatically considered a raceway. Therefore, you might need to use some type of conduit or other protection to shield the cable from damage. This could involve using metal or PVC conduit sleeves in certain areas, or ensuring the cable is securely fastened to the trusses in a way that minimizes the risk of abrasion or impact. Secondly, NEC Section 334.15c requires that non-metallic cable not be installed where it would be subject to excessive heat. The truss space above a drop ceiling can get quite warm, especially in the summer months. Therefore, you should take precautions to ensure the cable is not exposed to excessive heat. This could involve using a higher temperature rated cable, ensuring adequate ventilation in the truss space, or running the cable in a cooler location. Consider the ambient temperature in the truss space and compare it to the cable's temperature rating. If the temperature exceeds the cable's rating, it could lead to premature degradation and potential safety hazards. Thirdly, NEC Section 334.15d requires that non-metallic cable not be installed where it would be subject to moisture or condensation. The truss space above a drop ceiling can be prone to moisture and condensation, especially in humid climates. Therefore, you should take precautions to ensure the cable is not exposed to moisture or condensation. This could involve using a moisture-resistant cable, sealing any openings in the truss space to prevent moisture intrusion, or running the cable in a location where it is less likely to be exposed to moisture. Inspect the truss space for any signs of leaks or condensation before installing the cable. If you find any, address the underlying issues before proceeding. If you can meet all of these code requirements, then running non-metallic cable within the open web truss space above a drop ceiling would be permissible. However, if you are unsure whether or not you can meet all of these requirements, it is best to err on the side of caution and use metal-clad cable instead. Metal-clad cable is generally more resistant to physical damage, heat, and moisture than non-metallic cable, making it a safer option in these types of environments. Also consider local amendments to the NEC, because jurisdictions can have stricter rules than the base NEC requirements. Always check with the local electrical inspector to make sure you are following all applicable codes. Ultimately, the decision of whether or not to use non-metallic cable in the open web truss space above a drop ceiling is up to you. However, it is important to be aware of the code requirements and to take the necessary precautions to ensure that the installation is safe and up to code. Make sure you are aware of the specific type of non-metallic cable you are using. Non-metallic cable comes in several types, each with its own set of characteristics and applications. For example, non-metallic type B cable is the most common type of non-metallic cable, and it is suitable for use in dry locations. Non-metallic type UF cable is designed for underground use, and it is resistant to moisture and corrosion. Select the appropriate type of non-metallic cable for the specific application. Pay attention to the ampacity of the cable. Ampacity is the maximum amount of current that a cable can safely carry. The ampacity of a cable is determined by its size, type, and insulation. Make sure to select a cable with an ampacity that is sufficient for the load it will be carrying. Refer to NEC Table 310.15b16 for ampacity ratings of different types of cables. Do not exceed the cable's ampacity rating, because that could cause the cable to overheat and potentially start a fire. Use appropriate connectors and fittings. When connecting non-metallic cable to electrical boxes or other equipment, use connectors and fittings that are specifically designed for use with non-metallic cable. These connectors and fittings will ensure a secure and reliable connection. Do not use connectors or fittings that are not designed for use with non-metallic cable, because this could damage the cable or create a safety hazard. Securely support the cable. Non-metallic cable must be securely supported to prevent it from sagging or coming into contact with other objects. Use cable staples, cable ties, or other approved methods to support the cable. Space the supports according to the NEC requirements, typically every 4.5 feet and within 12 inches of boxes or fittings. Do not allow the cable to hang loosely or to come into contact with sharp edges or other potential hazards. Protect the cable from physical damage. Even though non-metallic cable is sheathed in a protective covering, it is still susceptible to physical damage. Take precautions to protect the cable from being crushed, cut, or abraded. If the cable is installed in an area where it is likely to be damaged, consider using a conduit or other protective measure. Properly ground the electrical system. Grounding is an essential safety measure that helps to protect people from electric shock. Make sure the electrical system is properly grounded in accordance with the NEC requirements. This typically involves connecting the grounding wire in the non-metallic cable to the metal enclosures of electrical boxes and equipment. Test the installation. After completing the installation, test the wiring to ensure that it is working properly. Use a multimeter or other testing device to check for continuity, voltage, and current. Verify that all connections are secure and that there are no shorts or ground faults. If you find any problems, correct them before energizing the circuit. Consider future accessibility. When running cables above a drop ceiling, think about future maintenance or modifications. Ensure that the cables are accessible for inspection, repairs, or additions. Avoid burying cables under insulation or other obstructions. Leave enough slack in the cables to allow for easy access and manipulation. Label circuits clearly. Label each circuit breaker or fuse in the electrical panel to indicate the circuits that it controls. This will help to prevent confusion and make it easier to troubleshoot problems in the future. Use a permanent marker or label maker to create clear and legible labels. Keep accurate records. Maintain accurate records of the electrical installation, including the location of cables, the size and type of conductors, and the ampacity of circuits. This information will be valuable for future maintenance or modification. Store the records in a safe and accessible location. Remember that electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electric shock. If you are not comfortable working with electricity, hire a qualified electrician to do the job. When working with electricity, always turn off the power at the circuit breaker before touching any wires or equipment. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work alone, and always have someone nearby who can assist you in case of an emergency. Stay informed about changes to the electrical code. The electrical code is constantly evolving to reflect new technologies and safety concerns. It is important to stay informed about the latest changes to the code and to ensure that your electrical work is in compliance. Attend continuing education courses, read trade publications, and consult with experienced electricians to stay up to date. Non-metallic cable is a versatile and cost-effective wiring method that is widely used in residential and commercial buildings. However, it is important to understand the code requirements and to follow safe installation practices. By taking the necessary precautions, you can ensure that your non-metallic cable installation is safe, reliable, and in compliance with the electrical code. Consider the weight load on the trusses. While non-metallic cable is relatively lightweight, the cumulative weight of multiple cables and other equipment can add up. Ensure that the trusses are capable of supporting the additional weight without exceeding their load rating. Consult with a structural engineer if you have any concerns about the weight load. Be aware of potential pests. The space above a drop ceiling can be a haven for rodents and other pests. These pests can damage non-metallic cable by gnawing on the insulation or using it as nesting material. Take steps to prevent pest infestations by sealing any openings in the truss space and using pest control measures if necessary. Regularly inspect the cables for signs of damage caused by pests. Consider the impact of other trades. Coordinate your work with other trades such as HVAC technicians and plumbers who may also be working in the space above the drop ceiling. Ensure that your cables do not interfere with their work and that they do not damage your cables. Communicate clearly with other trades to avoid conflicts and ensure a safe working environment. Document any deviations from the code. If you encounter any situations where you need to deviate from the code requirements, document the deviations and the reasons for them. Obtain approval from the local electrical inspector before proceeding with the installation. Keep a record of all approvals for future reference. Use surge protection devices. Install surge protection devices at the electrical panel and at sensitive electronic equipment to protect against voltage surges. Voltage surges can damage non-metallic cable and other electrical components. Surge protection devices can help to prevent damage and extend the life of your electrical system. Consider using arc fault circuit interrupters or SIs. SIs are circuit breakers that are designed to detect arc faults, which are a common cause of electrical fires. SIs can help to prevent fires by shutting off the power to a circuit when an arc fault is detected. SIs are required by the NEC in many areas of the home, and they are a good idea to use in commercial buildings as well. Inspect the installation regularly. After the installation is complete, inspect the wiring regularly to ensure that it is still in good condition. Look for any signs of damage, such as cracks, cuts, or abrasions. If you find any damage, repair it immediately. Regularly inspect the connections to make sure that they are still secure. Ensure that the supports are still holding the cable properly. By inspecting the installation regularly, you can identify and correct any problems before they become serious. In addition to the specific requirements for non-metallic cable, there are also general requirements for all electrical wiring. These requirements are intended to ensure that all electrical installations are safe and reliable. Some of these general requirements include using approved materials, following proper wiring methods, and grounding the electrical system. Make sure you are familiar with all of the general requirements for electrical wiring before starting any electrical work. Electrical codes and standards are developed and maintained by organizations such as the National Fire Protection Association or NFPA and Underwriters Laboratories or UL. These organizations develop and publish codes and standards that are designed to protect people and property from electrical hazards. The NEC is the most widely adopted electrical code in the United States. UL develops standards for electrical products, and it tests and certifies products to ensure that they meet those standards. When selecting electrical products, look for the UL listing mark. This mark indicates that the product has been tested and certified to meet UL safety standards.